Hey, how's it going? Today we're going to be covering how to graph tangent functions. So tangent functions have this really unique pattern to them. So instead of a wavy line like we saw with sine, that looked like that, we have this periodic increasing function, and that's our tangent. The tangent function is undefined for certain values. That means it has an asymptote. It means that all these things here are asymptotes. And so these arrows indicate that it goes on into infinity. And so because it goes on into infinity, there is no amplitude. It has infinite height. And so on a tangent function, we actually see that it repeats more often than the sine function. The sine function takes 2 pi, while the base tangent function only takes 1 pi to repeat. And so that means the period is, instead of being 2 pi over b, is just pi over b. And we have all these asymptotes at odd multiples of pi over 2. What does that mean, odd multiples of pi over 2? Well, let's take a look at that. When I say odd, I'm meaning like odd numbers. 1, 3, 5, 7. And so I'd say like 1 pi over 2. 3 pi over 2. And 5 pi over 2. We can also go negative with negative 1 pi over 2 and negative 3 pi over 2. And all of these are also affected by the b value. So it's not just pi over 2, but it'd be pi over 2b. So the greater that b value, the more often we'll see those asymptotes. Let's take a look at that. So let's graph our first couple. Here we see 4 tangent x. So here our period is pi over b. And so that's going to be just pi over 1 or pi. It's easier to think about then, though, where are the asymptotes? And remember, I said that they would be at odd multiples of pi over 2b. So with b just being 1, so that's going to be pi over 2, 3 pi over 2, 5 pi over 2, and same thing going into the negatives. Negative pi over 2, because that's negative 1, and negative 3 pi over 2. So let's graph those asymptotes. And so the first one's going to be at pi over 2. Next one's going to be at 3 pi over 2. And the next one will be at 5 pi over 2, which is not on our graph. And then we have negative pi over 2, negative 1 pi over 2. Remember, the odd multiples. And negative 3 pi over 2. Now let's graph our tangent function. The tangent function crosses through the origin when it's not translated. And so we're just going to see this curve, this almost like a cubic function curve. And so since it goes through here, it's also going to go through at pi, because that's our period, and go through at 2 pi. And the same in the reverse direction, or in the negative direction. And that's our very first graph of a tangent. Things aren't going to get any very crazy after this, so let's just look at one that actually has some more interesting transformations. So let's look at this next one. This one is negative tangent of 1/2 x. Its period is pi over b, which is pi over 1/2, or 2 pi. And so it will have asymptotes there, then, at pi over 2b, odd multiples of pi over 2b. So pi over 2b, so pi over 2 times 1/2, is pi over 1, or pi. So at odd multiples of pi, which would be pi, 3 pi, negative pi, and so we'll have asymptotes at pi, 3 pi, which is off the graph, and negative pi. And then we know it goes through the origin. But what do we do about that negative? That negative means that we're going to start out by going down now instead of going up. And so if you wanted to be really accurate, which I wasn't on this first one, you can say that at the halfway point between your intersection, your intercept, and your asymptote, you're going to have that a value there. So here, that a value is -1, and so we would have that here. And then you go the reverse way as well. The period is 2 pi, so we have another point here, another point there. Remember, it's periodic, so it's just the same thing over and over. -2 pi, down there. And that would be our graph. Now, if I were to have made this first one more accurate, let's say that we're trying to be more accurate now. We would pay attention to the fact that a equals 4. And so halfway between our point and our asymptote, I would have been at 4 instead, and -4. So it would have been even skinnier. Now, if you want to, you can go through and correct all those. But I'm going to just leave mine the way it is. Because it's fine. If we wanted really, really accurate stuff, we can always just graph it on the calculator. Let's do this next one. So our period is going to be pi over b, which is pi over 2. And we recall that the asymptotes will be at odd multiples of pi over 2b. So that's going to be pi over 4. So that's going to be pi over 4, 3 pi over 4, 5 pi over 4, and then, in the negative direction as well, negative pi over 4. So that's going to be pi over 4, 3 pi over 4, 5 pi over 4, and so on, and in the negative direction as well. And then we can graph our function. So this one says 5 over 2. So again, if I wanted to be accurate, I can go to wherever 5 over 2 is, which is about right here. and then halfway between our intercept and our asymptote, and then graph that. But as long as you're getting the points, the intercepts right and the asymptotes right, that's really the key part here. Because whether I draw it like super accurately or not, it's not going to really change the general shape. Now, it is important to pay attention to negatives, like what we had up here. It is important to pay attention to negatives to see whether it's increasing or decreasing, but the general shape's fine. Let's do one more before we cut it for the day. Let's do 3 tangent 2 over 3x. So our period's going to be pi over 2 over 3. And let's just do that division over here. Pi divided by 2 over 3, which is pi times 3 over 2, which is 3 pi over 2. And then here, remember where we had for our asymptotes is going to be pi over 2 times b, so 2 over 3 down there, which is going to end up being odd multiples of 3 pi over 4. Now, that's going to be weird to think about. You have to think about, oh, well, that's 3 pi over 4. Okay. And then that's going to be 3 times 3 pi over 4, which is 9 pi over 4. And then 5 times 3 pi over 4, which is 15 pi over 4. But if you can get the first asymptote correct, you can always just use the period again to find the next one. So our first asymptote is 3 pi over 4. That's right here. And then 3 pi over 2 after that is just going to be over here. And then in the other direction, 3 pi over 2 below that, or negative 3 pi over 4, and negative 9 pi over 4. Our a value is 3, so again, if I wanted to be accurate, I could go halfway between my intercept and my asymptote, put in a value at 3, and then also do the other direction but negative. And so, and then you just repeat. I'm more likely to do a more accurate graph when I have more space. When I have less space, I'll typically just sketch it. Well, sketch in a looser manner anyway. Okay. And that's graphing tangent lines. If you have any questions, feel free to ask me in person or leave a comment on this video. Thanks, and have a great day.